A weird time to be in manufacturing technology because we have this chase, this weird urgency to implement AI just to say that you implemented AI. The C-suite or the board over here is like, hey, what are you guys doing to make sure that you're AI focused, that we're going to have manufacturing of the future? And the manufacturing team over here is like, dude, my guy, I am busy, okay? So we start this kind of strange innovation theater where we're implementing AI just to say that we implemented AI. We're doing things like putting a spoiler on a forklift and being like, hey, that was super transformative. Especially for operations and manufacturing, we can't afford to waste time that's not focused on real output because we're constantly dealing with market disruption, supply chain problems. So if your AI isn't actually helping, it's not a strategy, it's just a distraction. So let's break down all of the weird, fluffy, constant experimental type of innovations. It's not a science project, it's a business strategy. So let's talk about real business and numbers to showcase what smart manufacturing actually means and how when you go to the board, because they're giving you this pressure, you can actually implement something that's going to help you save time, be more efficient, and make your job more fun, easier, all the things. And like usual, I'm gonna use an actual business, real live results case study to talk about it because I don't know about you, but I'm super sick of the theoretical pieces around AI. Yeah, that all sounds awesome that you increased efficiency and reduced waste by 20%, but what does that actually mean as far as what I can do tactically to implement that in my organization? So let's dig into real numbers. But before we do that, we have to talk about, especially domestically here in the States, just the growth of overall smart manufacturing. So globally, smart manufacturing is valued at around $400 billion in 2024 US dollars and is projected to grow over $900 billion US dollars by 2034. And the most important number, in my opinion, for this market is focusing on kind of mid-sized manufacturers here in the US, because just smart manufacturing here was valued at right around 80 billion in 2024 and is anticipated to reach 200 billion by 2034, which is over 150% increase in just 10 years. And the only way to do this is through smart technology. Looking at your manufacturing system, whether it be your shop floor, your automation processes, and seeing where you can utilize predictive analytics, predictive maintenance, sensor technology to make your manufacturing more efficient. So let's dig into an actual case study example. And I'm going to talk about John Deere, which is an American company, and its partnership with Intel. And the reason I'm going to do that is because we have this amazing manufacturing community in the Midwest, a lot of which are our clients here, that have so much opportunity when it comes to implementing smart manufacturing. So this is on a macro level, huge American company, but still something that you can take some insights from and look at your own manufacturing operations and see where could I plug a few of these in. This project focused specifically on AI-based welding and overall quality control. So John Deere already used some automation in their manufacturing with the gas metal arc welding. So this is like a long robot arm that through automation executes a lot of your welding, which is safer and often more precise. However, they were still struggling with these little porosity defects, which were kind of like tiny little holes in the welds that trapped the gas inside, which was very, very difficult to detect. And because it's hard to detect, then we have to deploy things like manual inspection methods so that we can make sure that we're finding these before anything else causes an issue in the manufacturing process. So stop here. They identified an actual pain point in their business, right? They're having an issue with this porosity quality assurance process. So now that we got the pain points, we need the partner. So John Deere went out to Intel and was like, hey, I'm having issues with this. Can you help? Again, time out. They chose an established partner. I can't tell you the amount of times the clients have come to us with just a dumpster fire of an implementation because they chose a vendor that seemed really cool, that were on the cutting edge of manufacturing smart technology, but had no actual implementations under their belt, which is just asking for disaster. Please, if you take nothing else from this video, use an established partner. It does not have to be your MES provider, it doesn't have to be your ERP vendor, but make sure that you're doing your due diligence to ensure that your partner has implementations that they've proven success, proven results. So what technology did they identify that could help them through the situation? So they looked at artificial intelligence and automation, machine learning, computer vision, which is an interesting one, Internet of Things, and then ultimately real-time data and analytics. So how did they implement that? And I'm going to start with computer vision because I think it sounds the coolest. So this system uses advanced computer vision, so very precise neutral neuron network that interfaces with the actual engines to monitor the process in real time. So it gives you kind of like this superhuman look into what's going on in the manufacturing process. The other thing that's big that a lot of companies can use today is just simple AI in defect detection. So what they used here is when the robot arm goes in to make the weld, the AI video feed analyzes that in real time to detect any variances or defects that might be going on. And the step further than that is the immediate process intervention. So that defect is detected, right? That variance is detected, and the system automatically stops, allowing for that corrective human-machine relationship before the defect propagates further in the production line, or it's hard to find. Now, there's a lot of iterations to this. It's important to remember that this does not happen overnight. We have a client that uses a very similar process in metals manufacturing, but when the variance is detected, right, that variance could be that it's going to drop a huge pallet on the floor from its smart crane, big issue, right? Or someone sneezes next to it and stops the whole production line. Not a big issue. So it is not perfect going into this. Again, AI is not a magic bullet. It's a strategy and tool that needs humans to create the strategy and make it most efficient and effective for the outcomes that they've targeted. So what did they achieve? What are the outcomes that we're focusing on? Well, for starters, that AI-powered visual inspection of the welds decreased inspection time by 80%. And that's for large assemblies. So think about like a big tractor frame that have hundreds of wells on it, decrease that time by 80%. They also had a huge increase in efficiency in welding. So for that real-time location and the replenishment systems, that led to 10% increase in welding efficiency and 40% faster replenishment of welding materials. And the last stat I'll share, even though there's tons more, which you guys can check out, is just overall quality control. And this is what I talked about in the beginning. Very easy to implement now. You don't need robots or drones zooming across your manufacturing floor to look at just overall quality of your production line. So the digital inspection tools powered by automation and AI can inspect over 18,000 parts on a combine in less than 6 seconds. And that's huge. So vastly increasing the number and thoroughness of the inspection points compared to that manual process where they had to go find those little pockets of gas. So instead of getting overwhelmed by these fancy words and just using AI to use AI, these are actual strategies that you can look up as a manufacturer, whether you're a $20 million company or a $20 billion company. There are things in this list that you can activate today to make AI centered around actual outcomes, not just fancy words.